This is the final installation of our three-part virtual webinar series surrounding cloud-native workloads for Amazon FSx for NetApp ONTAP. Next slide, please. Today's session is going to be surrounding databases, self-managed and managed databases within AWS's platform. And for the agenda today, we're going to start with a general overview on managed and self-managed DBs on AWS. Followed by a well-architected framework of best practices for running databases on AWS. We're then going to jump into the overview of Amazon FSx for NetApp ONTAP, what it is, what it has to offer, what it looks like on the platform, and we will take questions in the chat regarding that as well. Then we're going to end today. There we go. Then we're going to end today with a demo, a customer example, and we will save some time at the end to address the questions that we get in the chat. So with that, I will let Phil take over here for the introduction on databases.
Thanks, Adam. Next slide, or next spacebar, I guess. Thank you. Okay, so first off, let's just kind of cover what are the database options within AWS. We have a managed component and then a self-managed, but firstly, on the managed side, we have Aurora, which is our global scale managed database, and that has a MySQL or a Postgres offering. We have RDS, which is our managed relational database service, and that offers more mainstream such as SQL Server, Oracle, things like that. Neptune is our graphing database if you have that kind of data set that really needs to map your relationships. DocumentDB, which is our managed JSON document database. DynamoDB, which is our NoSQL key value database. And then Keyspaces, which is our Cassandra compatible database service. So those are managed. We also have our self-managed databases, which is probably the database platforms that you're probably running on premises or familiar with, SQL Server, Oracle, etc. And there's some, and with the self-managed, there's also the component of running the Amazon EC2, your compute, and then using our storage services to host the databases. And there are various things to consider, the key considerations. So on the managed database side, obviously we've said it's managed. You as a customer does not need to worry about launching the operating system, patching the operating system, installing and patching the database platform. That's all part of the offering of a managed service, among many other things. There's the scalability of a managed service where you can do configurations within some of these platforms to say, as my workload increases, make some adjustments to my platform to accommodate that and scale back down. And then it's a pay-on-demand service. So if you need it for a month end and then you don't need it for the rest of the time, you can power it down and not incur costs, but so as needed. On the self-managed database side, the considerations are really that fine-tune, by which we mean if you have specific storage configurations or you need specific custom ODBC drivers or application, something that you need to install within the OS, that's where the self-managed database comes in, because you have the ability to log in and make those kind of changes at the operating system level, at the application level, the database level, just to fine-tune the performance or however you need to do that. And then obviously there's a support for quite an array there. We've the graphic shows you a few of the handful there. And then it's also it opens up the ability to bring your own license, BYOL, which can be a very cost-effective strategy in some cases. So for today's session, we're really going to drill into the self-managed database and specifically SQL Server with our Amazon FSx for NetApp ONTAP. So what are the challenges that we're going to recognize and address in today's conversation? So first off, and always important, is resilience and protection. What do we mean by that? Your backups, your restores, your high availability, your disaster recovery, all the elements that we're protecting our data for, those are how we're going to do that. And that's something we're going to directly address in the conversation and the demo today. Next, we have performance. A database needs to be performant to keep your customers happy. So, along with the classic, the throughput, the IOPS, we also need to make sure that the latencies are low enough that it meets any SLAs you need to have and such. So that's really, we're going to drill into that metric when we talk more about FSx. And then also, creation time and costs. If it takes you, X period of time to create a database, refresh a database, those timings can have a direct cost. If you have to take your reporting environment offline for 4 hours to refresh the data, that can be a costly gap in operational. So how that can be done and how that can save on costs, and then costs, last but certainly by no means least is the cost performance optimization. We're going to show in some of the later slides here how we can really reduce compute, reduce the licensing footprint, and really find that balance between cost effective and performant. And we're going to show you today a few steps around how FSx can help with that conversation. Next slide, please. So here at AWS, we have something called a well-architected framework. It's a 6 pillars that we can do to kind of really address and understand your needs, your application, and really provide a good structure to define the best way to implement that. So for the purposes of today's conversation, we'll really kind of drill into 4 of these pillars. The reliability, your backups, your restores, HA, then the performance, we talked about the thresholds, the low latency, and then the operational excellence, which is going to go back to how can we most cost effectively, restore, create databases, and make sure that we're doing that as fast as possible for a cost-effective manner. And then cost, obviously, again, what are the tools we have that we can show you to really fine-tune that environment and make sure you're getting the most performance for the best price, etc. So that's the well-architected framework. There's a whole lot more that we'd be happy to talk about in a different session, but that's really where we're going to focus today's conversation. Next slide, please. And with that, I'm going to pass it over to Semyon to talk about Amazon FSx for NetApp ONTAP.
Thank you, Phil. Hi, everyone. I'm Semyon Mazur. I'm product evangelist here at NetApp. And in order to see how you can cope with the challenges that Phil just discussed, there's a service called Amazon FSx for NetApp ONTAP, which is an expert storage for well-architected databases on AWS. It provides powerful database protections and performance with exceptional cost efficiencies. And let's delve a bit deeper to understand what that means for you in all the challenges that we just mentioned. So first, what is FSx for ONTAP? It is one of the storage services that AWS offers. FSx for ONTAP leverages NetApp's industry-leading technology, which has been developed over the past 30 years and utilized by numerous Fortune companies and large corporations with the most demanding requirements. What makes FSx for ONTAP different from other storage services is that it has a comprehensive set of features that turn into expert storage for any workload. These features can be grouped into 5 main pillars: accessibility, resilience and protection, data security, price performance, and data mobility. For accessibility, FSx for ONTAP provides file, block, and object storage on the same file system. It offers a unique multi-protocol access supporting NFS, SMB, and iSCSI. For resilience and data protection, FSx for ONTAP is highly available by default and offers many data protection capabilities to ensure your data is protected, both locally and with remote copies, which we'll cover in the next few slides. For data security, FSx encompasses various capabilities related to data integrity and isolation, integration with Active Directory, file tracking, storage immutability to prevent unauthorized data deletion, and malware protection, and also other data security features. For price performance, FSx for ONTAP provides high throughput, high IOPS, and inherent capabilities to reduce data footprint. FSx for ONTAP delivers both high performance and cost efficiencies. And for data mobility, FSx for ONTAP offers numerous capabilities for data movement, creating new copies, cloning data, and establishing new environments. And this significantly contributes to running databases, and we will dive into it shortly. Now, let's open each of the challenges that Phil mentioned and see how FSx for ONTAP helps to deal with them. So let's start with reliability. An organization requires the data to be protected, and FSx for ONTAP offers several layers of data protection. First, each FSx for ONTAP file system is highly available by default, supporting single and multi-availabilities on deployments. The first layer of data protection is provided by local snapshots, which are read-only point-in-time images of data. These snapshots are lightweight and created instantly. They are also database consistent, making it easier to recover without any roll-forward activities. These snapshots serve as the initial layer of data copies stored locally on the same file system, allowing for restoration in case of data corruption. The second layer is disaster recovery. FS6 for ONTAP offers advanced capabilities with cross-regional replication using highly efficient replication engine called SnapMirror. This ensures the presence of an additional mirror copy of the data, even if a full region experiences an outage. In such cases, the database can fail out to the secondary region immediately. The third layer of data protection is backup, which allows for additional copy of the data in different format. This provides an extra layer of protection in cases of emergencies. And we will also demo today how easily you can create those backups. FS6 for ONTAP is integrated also with AWS Backup, and it's highly efficient due to its utilization of NetApp snapshots. And this results with fast backup rapid restoration and cost savings. Next, let's talk about performance efficiencies. FS6 for ONTAP delivers high performance to ensure low latencies for databases. It offers high throughput of 6 gigabytes per second and even more than that. Additionally, it incorporates a unique in-memory cache and NVMe cache, which further enhances the performance of frequently accessed data. And with SSD disk, FS6 for ONTAP provides hundreds of thousands of IOPS, ensuring that your databases receive results within the required time frame. Next is operational excellence. Most organizations have multiple database environments, including production databases and additional databases for development, testing, pre-production, schema validation, and more. And typically, each additional copy requires the same amount of storage as the original. However, FS6 for ONTAP offers a different approach. FS6 for ONTAP creates snapshots, which we just mentioned before, and those snapshots are lightweight and created instantly without affecting your production environment. Now, based on this snapshot, new environment can be created by creating thin clones of these snapshots. And they span up from the snapshot without impacting performance capacity or cost. And the best part about those clones is that they perform just like real copies of the data. They are fully writable. And you can create and share as many usable copies of the production as needed without affecting the production environment or granting access to it. So instead of consuming 550 or 500 times the storage capacity, you achieve the same result using the same amount of storage. And cloning not only reduces the database cost, but also shortens the development cycle, resulting in lower development costs and faster time to market. Finally, FS6 for ONTAP incorporates several built-in data reduction capabilities that help save on cost. I'll present them now, and later I'll show a customer example to showcase those capabilities. It begins with various data reduction technology, including deduplication and compression, which effectively reduce the capacity of your data. The NetApp snapshots are highly efficient, further saving on storage capacity and associated costs. And the real game changer is thin cloning. Thin cloning not only shortens the development cycle, as we just mentioned, but also significantly impacts your cloud bill. Instead of paying for multiple copies of data, as we said, 550 or 500, you only pay for one. The initial environment is smaller than the original 100% capacity thanks to FS6 for ONTAP storage efficiencies, and then subsequent copies only add a fraction of the data, resulting in a combined total of 100% of the data. The performance that we mentioned are configurable. This means that environments that do not require the highest level of performance, which comes with a cost, can be configured for lower performance levels. And because of the way FS6 for ONTAP is integrated within AWS, it enables you to utilize network bandwidth to the storage layer, and by that achieve the same performance with fewer EC2 cores compared to other storage services. And this can lead to significant cost savings. Additionally, with storage-based replication, FS6 for ONTAP also allows to save on database licenses. And to delve a bit more on the last 2 points, I will ask Phil to explain us how it works.
Phil, you're on
mute.
Sorry about that. Can we go back one slide? I just wanted to touch on those last 2 points that you talked about, Semyon. Yeah, so
Sure.
the messaging we want you to understand here is because the storage replication is network traffic going to your Amazon FSx for NetApp ONTAP storage system, that is different than the EBS elastic block storage capabilities of our EC2 compute nodes. So when you're shifting that replication and data traffic to that different medium, it potentially can make you eligible to use a much smaller compute size. Because a lot of times your storage requirements will be a big driver in what kind of size compute you run. But when you shift that traffic to the network tier versus the EBS channel, it can have potential to reduce the compute. So next slide, please. So now that we've talked about how can we reduce the compute based on shifting the storage traffic to the network card, the next piece of the puzzle to further optimize is how can we reduce our license costs. So we've taken and can you hit the space on this, please? We've taken our R6i 12X large as an example here. It's got 48 vCPUs presented when you launch it. Now, maybe we started at a 24X large and we're able to downsize to a 12 by virtue of moving the storage traffic to the network card. We can further optimize that by looking at the overall compute and say, okay, we need all the memory that an R6i is going to provide us. It's a database, it loves memory, let's give it everything that we can. But it's also not a CPU-bound application. It can operate with a whole lot less than 48 cores. So using something called optimized CPU, which allows you to configure the amount of cores that are presented to the operating system at launch time, I can say instead of the 48 cores this comes with, only present 8, because that's all my application needs. It needs all the memory I can give it, but it only needs 8 cores. What that means is you also, if you're bringing your own licenses, only need to license the 8 cores. So that, going from 48 cores of SQL Server Enterprise licensing down to 8, 83%, and that's a significant savings in dollars if you're paying for those licenses, because 48 to 8, 83% is a large number. So that's the second piece. We want to bring the compute down by moving the storage traffic to the network card, and then we want to further optimize by making sure you're only paying for the licenses and cores that your application needs. So that really two-step to really reduce that compute size and make it a cost-effective design. Next slide, please. Okay, so we've done a bunch of talking. Let's see how a lot of this is actually going to work. Next slide, please. So first off, let's kind of do a high level, how is the demo going to flow? So step one is going to be taking those backups, and the backups are going to happen through that snapshot that Semyon talked about. We'll have our production database. That's going to be our highly available cluster instance that's connected to our Amazon FSx for NetApp ONTAP storage. And then we'll also have our dev environment, which is going to be a standalone instance, our lower environment, but it will also be attached to our storage through iSCSI. So after we take that backup, we're going to restore the backup over the top of the production database we just took it from to show some protecting data and rolling back changes if we need to. So that'll be the first operation, is to restore. The next step will be to take those same snapshots and leverage them to clone that whole production environment into the dev environment. And you're going to see some pretty amazing numbers there. For example, here, we're going to have a 3.1 terabyte database. And I'll let you make some guesses in your mind about how long you think it's going to take to clone that. And then when we do the demo, we'll see how close you were. Okay, so that's the demo. And then the tooling we're going to use, which is an important part of the conversation here, is SnapCenter. This is a management tool that talks to the FSx technology. It allows you to initiate those snapshots, initiate those clones, take the backups, do scheduled backups, T-logs, full backups, all the things you're used to through a SQL Server backup strategy. It is a tool that's provided as part of having that Amazon FSx for NetApp ONTAP functionality of the service. So this is a free-to-use tool for those, when you have that configuration with an AWS. So there's no, it does need to be hosted on EC2, but it's a great tool to use. With that, let's jump into the demo. And this is a pre-recorded demo, just because we're going to do some fast forwarding. You'll see here we have our SQL instance on the left there, and that's going to be where we're housing our production database. We have our TPC 1000, that's 147 gig. And our TPCC 30,000, that's our 3.1 terabyte database. Okay, so this is SnapCenter, and here we have our databases that are being protected. And you'll see here we have the, actually, let's jump over and show you these are the pre-configured backups. So we have daily backups, system backups that are running daily. Then we have T-log backups that are running every 15 minutes. And these are all pre-configured to run against the databases that can see. But here you'll see we have those databases. And the first thing I want to do is initiate the backup of the 147 gig database. And this is just telling me it's an out-of-band backup, and that's fine. So you'll see the bottom here, we have our monitoring of the jobs that are running. So if we pull that up, we'll see that it took about 9 seconds to complete that operation. So 147 gig backup, 9 seconds using that snapshot technology. So let's go ahead and do the same operation, but now we're going to use that 3.1 terabyte database. We're going to do another backup now. Yep, next, and we're just going to say yes to that message. And then we'll look at the activity log at the bottom here, and you'll see it's running, and click on there, and we'll see how long that took. So this one, 3.1 terabytes, also took about 9 seconds. And that's really that snapshot technology we're talking about, and how it really can be a game changer for your very large databases. Okay, so let's go ahead and refresh what we have here to pick up those last 2 backups that we just took. And what we're going to do here is we typically took backups. Now what I want to do is show you making some changes to the big database. So let's run this, and you'll see that table doesn't exist. So the backup we just took, table doesn't exist. So let's go ahead and create a table, drop a few records into there, and run that. And okay, so now we have a table with 6 records living in the 30,000, the large 3.1 terabyte database. So let's go ahead and do another backup so we can pick up the change that we just made. So we'll go ahead and run that. Again, this is running against the 3.1 terabyte database. We'll wait for that to complete, and then we'll check the status. And this one took about 12 seconds, so it was pretty close. Okay, so we've got that backup taken. So now we have a backup pre-table being created and then post-table being created. So let's go ahead and just do a refresh here, and that's going to show the backups that we took. Click there, and then hit the refresh up on the console here. Okay, so now we have those 2 last backups, one before we created the table and one after we created the table. So what I'm going to do is grab the database that we took before we created the table, and we have a few options here. We're going to do basically a restore with recovery. We also have an option to do to an alternate host if you want to restore to a different server, or basically do existing database files, more of an attach operation. But we're going to do a traditional restore over the top. There are no T-logs here. It is supported, but we're not going to use those today. I am going to check to overwrite the existing production database and remove that table we just created. Okay, so here we have options. We can do operational, which is basically with recovery. We have a non-operational, meaning we are going to allow additional transaction logs to be applied if we're going to do a rolling backup. But here we're just going to do operational, which is immediately usable. We could send an email. We're not going to. That's the summary. Okay, so we fired off the database backup. Let's go ahead and check the status of that. And we're going to do a little fast forwarding here to get to the endpoint. Okay, and that completed. That took about 8 minutes, give or take. That's doing a complete restore over the top of the existing database. So there's actually a bit to do there. And now we can go check that system and run that first command again. So now with that restore, the table is being removed, and now we remove that change from the production environment. We could have dropped the table, which would be less dramatic, but to show that we can do the restore. So now what I want to do is I'm going to take the backup that I made with the table, and instead of restoring it, I'm actually going to do a clone operation. So this is the production database that I'm going to send, and I'm going to select our standalone dev box, SQL Dev here. So this is there. We're going to select the instance. SQL Dev is the instance. I'm going to give the database a name. We'll call it -clone, just so we see it. And then we have choice to either auto-assign a mount point or actually provide a directory and have the mount point hosted under that directory. But we'll leave auto-assign for today. Again, there are no T-logs here. It is supported, but we're not going to use those today. If we had to do some post-restore, pre-restore, cleanup for the production data being, desensitized, whatever, we could run that here if we wanted to. No email configuration, so we'll skip that. And then the summary. Okay, so this is the clone operation of that 3.1 terabyte database. So that is running. And these are application consistent, remember. So there's no crash recovery happening here because it is an application where it quiesced the disk. And you'll see there, that took 30 seconds. 30 seconds to restore 3.1 terabytes to dev. So that, I don't know what number you had in your head when we talked about it earlier, but 30 seconds for 3.1 terabytes to make your dev environment completely refreshed. That's, as I said, I think that's a game changer for refreshing lower environments. So the whole demo you just saw was all GUI based, which is great. But obviously, if you want to do any kind of automation, we need to have a PowerShell version of this, or a script-based version. So I'm basically going to repeat the demo you just saw quickly, but completely PowerShell, command line driven. So I just connected to our system center, and now I'm going to initiate that first backup you saw of the TPCC 1000, and that then we can check the status of that backup, and we'll run that just to see, and it'll give us the information about what the backup was called. It took this one took about 22 seconds, just kind of depends on what else is going on in the system. And now I'm going to run the full backup of the 3.1 terabyte database. And you'll see these commands are, you'll have this when you get the video recorded, so you can easily use this if you want to. But this is to really show you we can do the automation. We'll just grab the job ID, that 318, and we'll plug that in there. And then we'll run to get a status on this backup command. And this will give us, so this one took 9 seconds. So we can get this, you can see how this is going to lend itself very well to automation. If you want to, script out your lower environment refreshes to happen, after hours or every hour, whatever you need. So now we're going to do that restore over the top of the existing database. And we'll go ahead and check that 319 as the job ID, and we'll just check the status of that restore. And we'll run that. And that's going to give us this thing that we figure out the time there. And then the last piece of the demo that we did is that cloning to the lower environment. So here I'm going to run the clone command, all the same elements, but command line driven. And then we'll check the status of that job 323 is the code there. We'll plug that in there. And this is, again, the cloning to the lower environment. Let's run that. And we'll get the status for that one. And that actually took 21 seconds. So we took 30 seconds when we did it with the GUI. This time we ran it, it took 21 seconds. So again, it can go faster. It depends what else is going on in the system. So that was the end of the demo. I know it went fairly quickly there, but you will see the recording if you want to revisit certain pieces. But just demonstrating speed. Now, cloning a lower environment. I know if you've had to refresh lower environments in the past, it can be painfully long. Using cloning, I didn't incur an additional 3.1 terabytes on my storage system. I'm not paying for the double capacity like Simeon talked about. Now we have thin clones, but it took me less than 30 seconds to clone that low environment. It really is a game changer for refreshing a reporting environment, or just getting your developers the latest and greatest version of their dev test environments as they need to. Okay, and with that, we'll do next slide. I'll pass it back to Simeon.
Thank you, Phil. So we discussed the different capabilities. Let's showcase with a customer example of a financial service software company called Cesium. And they need to optimize their data refresh cycles and find a cost-efficient disaster recovery solution while maintaining consistent point-in-time view across multiple databases. So after evaluating several options, Cesium determined that FSx for ONTAP was the most suitable solution. And ultimately, they speed up their database snapshot creation in 5 times. They achieved an 80% reduction of database refresh cost. Moreover, FSx for ONTAP providing them with efficient disaster recovery environment that enhance the data protection capabilities, and it helped them to reduce storage consumption by 53%, resulting in 46 storage savings. The impact is significant, as you can see with the numbers on the slide. And this is just one example among many of how customers benefit from using FSx for ONTAP to optimize their databases. To summarize, FSx for ONTAP, with FSx for ONTAP, you can quickly create new databases environment with minimal cost. You can ensure database protection and meet strict RPO and RTO requirements through application-aware snapshot, advanced disaster recovery, and backup capabilities. You can maintain high performance with low latency, high throughput, high IOPS, and smart caching, and achieve cost optimization by utilizing fewer EC2 cores, save on database licensings, and leveraging storage efficiency technologies, resulting in potential cost reduction of up to 50%. Now, with that, we'll ask Adam to take us through the final slides.
Thank you, Semyon. Thank you, Phil. So what's next? Next slide, please. Whether your AWS journey includes containers with EKS, machine learning and AI, with Bedrock, or your CI/CD pipelines or self-managed databases, you can be assured that FSx for NetApp ONTAP is going to be the optimal storage service on AWS to continue this cloud-native journey. Next step, please. So here you can find a resources tab. This will include the landing page for FSx for NetApp ONTAP, a FAQ segment that answers a majority of the questions that you may see or may have from today. In there, you can also find tutorials and on-demand sessions as well. All of the documentation and technical documentation as well is included there, and a GitHub workshop for you to go into in your free time as well. Now, if you use this QR code here, you can continue the conversation with us by booking a follow-up meeting with your AWS or NetApp counterparts. We can assist you with deeper questions that you may have from this session, as well as getting you set up to try the service as well. So I'll leave this slide here for you to take your phones out and copy this QR code. But as we wrap up, I think this would be a really good time to address some of the questions that we have in chat. So question one